Welcome to Learn Commerce PU online classes. Don't forget to like our video and subscribe our YouTube channel for all the updates.
Welcome to our first PU Computer Science online classes. Now we know that in last class we studied many conversions, maybe the conversions decimal to binary, binary to decimal, or maybe octal to binary. So each and every conversion we know about this one. Now in today's class we are going to complete the next conversion name. The next conversion name is the hexadecimal to binary conversion. Okay, the conversion name is the hexadecimal to binary conversion. So ಈ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಈ ಕನ್ವರ್ಷನ್ ಅನ್ನು ನಾವು ಮಾಡಲಿಕ್ಕೆ ಹೋಗ್ತಾ ಇದ್ದೇವೆ. Now we know that in our hexadecimal conversion the hexadecimal number has totally 60 digits, correct? No, and the numbers from 0 to 9 and also the digit of ABCD have decimal equivalent of 10, 11, 12, 13, 14 and 15 respectively. Now how we are going to make the conversion, that is from hexadecimal to binary conversion. Okay, now we know that because in our hexadecimal to binary conversion, to convert any number that is from hexadecimal number to the binary conversion, we need to replace or convert the each hexadecimal digit with appropriate 4-bit binary number. ಅರ್ಥ ಆಯ್ತಾ ಎಲ್ಲರಿಗೆ? ನಾವು ಹೇಗೆ ಕನ್ವರ್ಟ್ ಮಾಡ್ತೇವೆ, ಯಾವುದೇ ಒಂದು ನಂಬರ್ ಅನ್ನು ಯಾವ ನಂಬರ್ ಅನ್ನು hexadecimal ಇಂದ ಬೈನರಿಗೆ ಹೇಗೆ ಕನ್ವರ್ಟ್ ಮಾಡ್ತೇವೆ, that means maybe to convert any number that is from the hexadecimal number to the binary number kia we need to convert, we need to replace the each hexadecimal digit with appropriate 4-bit binary number. Clear this point here? With the appropriate 4-bit binary numbers here. That means in one group we need to use the 4 bits. Clear this point here? Now before that only, before going to convert any number that is from the hexadecimal to the binary conversion, first of all I want to tell one important note about the table, and in this table first of all I want to complete 3 columns. The columns are the first column name is the decimal, second column name is the binary, and third column name is called as the hexadecimal. Clear this one? First column decimal, second column binary, and the next column name is the hexadecimal. Clear this point here? Okay, as we know that in our decimal how many numbers are that? Totally we can say that the decimal number contain totally 0 to 9, that is equal to 10 numbers, correct? No kya 0 to 9 kya, but also we can say that 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9, and we know that the decimal equivalent, correct? No, the digit, because we know that in our hexadecimal conversion totally 16 digits are there. Clear this point here? In hexadecimal totally 16 digits are there, and we know that in case of the digit of A, B, C and D have decimal equivalent of 10, 11, 12, 13, 14 and 15 respectively. So clear this point here? So ಹಾಗಾದ್ರೆ ನಾವು ಡೆಸಿಮಲ್ ಕಾಲಮ್ ಅಲ್ಲಿ ನಾವು ಹೇಗೆಲ್ಲ ನಾವು ವ್ಯಾಲ್ಯೂ ಅನ್ನು ಹೇಗೆ ನಂಬರ್ ಅನ್ನು ತಗೊಳ್ತಿದ್ದೇವೆ, 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9, and after that we know that the digit of our A, B, C, D and E have decimal equivalent of 10, 11, 12, 13, 14 and 15 respectively here. So clear this point? Now we completed the column of the decimal number, and now first of all we'll complete, before going to complete the second column binary, later words I will tell how we are going to complete the binary column. Before that I want to tell the column of the hexadecimal. Clear this point here? So hexadecimal we know that totally the hexadecimal has 16 digits, correct? No, and the number going to start from 0 0 to 9 in this case here, and later next one after the 0 to 9, sure we are using the alphabets. The alphabets are the A, B, C, D, E and F here. So like that only I am going to write the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8 here, and later now this is the hexadecimal column. Clear this part here. It is the third column. This column is the first one. This one is the second column, and this is the third. And here also when you are going to use the numbers, so 1, 2, 3. So the third column name is the hexadecimal column. So it is the continuation. Clear this part here. After the 8, how we completed, how we continued the decimal column, like that only it is the continuation of the hexadecimal number column here. So 9, okay, and later we know that because the decimal, correct, no, here the digit 10, 11, 12, 13, 14 have decimal equivalent to A. That means we can say that the digit A, B, C, D, E and F have decimal equivalent to 10, 11, 12, 13, 14 and 15. So clear this point here. ಅರ್ಥ ಆಯ್ತಾ ಎಲ್ಲರಿಗೆ? ಹಾಗಾದ್ರೆ ನಾವು ಯಾವ ಕಾಲಮ್ ಅನ್ನು ಕಂಪ್ಲೀಟ್ ಮಾಡಿದ್ದೇವೆ? ನಾವು ಜಸ್ಟ್ ವಿ ಕಂಪ್ಲೀಟೆಡ್ ದಿ ಕಾಲಮ್. ಒನ್ ಇಸ್ ದಿ ಡೆಸಿಮಲ್ and second and third column is the hexadecimal column. Now let's about the binary. How we are going to complete the binary column? Very easy method I will tell to complete the binary column here. So the easy method, first of all, see, we know that because in this case how many bits are there in binary group? So we know that the each group have 4 bit. Clear this point here. The each group have the 4 bit here, as we know that in our octal digit the each group contain 3 bit. Clear this point here. But in case of the binary of the hexadecimal, that means when you are going to convert any number from hexadecimal to the binary conversion, that means we can say that to convert, correct, no, the hexadecimal digit with appropriate 4-bit binary number here. So first of all, very easily, first of all you need to use 8 zeros. Clear this point here. So 1, 2, 3, 4, 5, 6, 7, 8. Clear this one. The 8 0 and the 8 1. Clear? The 8 0 and the 8 1. ಹಾಗಾದ್ರೆ ನಾವು 8 0 ಅನ್ನು ಯೂಸ್ ಮಾಡಬೇಕು. Very easy method. I will tell how to complete this 4-bit binary number. So we need, first of all, in first column we need to complete 8 0, okay, and 8 1s. Clear this point here. And later next one after that we need to complete in second, okay, in second number we need to complete 4 0, 4 0 and 4 1. Again it will go, it will continue the 4 0 and the 4 1, and later next one in third column 2 0 2 1, 2 0 2 1, 2 0 2 1. So it will go till our number 15. ಅರ್ಥ ಆಯ್ತಾ ಎಲ್ಲರಿಗೆ? ನಾನು ಫಸ್ಟ್ ಕಾಲಮ್ ಅಲ್ಲಿ ಎಷ್ಟು ಬರ್ದಿದ್ದೇನೆ? 8 zeros. Clear this count. The 8 zeros, later was I continued here 8 ones, okay, till our 15. I want to use here use the number, and later next one the 4 0 4 1, 4 0 4 1, like that I completed till number 15, and later next one after that 2 0 2 1, 2 0 2 1. So like that I need to complete, and lastly finally I need to complete as the 0 1 0 1 0 1 0 1 till the number 15. So clear this one. Otherwise if you know the number perfectly, then that means you can write, okay, together the number is the 0 0 0 0, okay, for the number 0, and 0 0 0 1 for the number 1, and 0 0 1 0 for number 2, and 0 0 1 1 for the number 3 here, 0 1 0 0 number 4, 0 1 0 1 number 5, 0 1 1 0 for the number 6, 0 1 1 1 number 7, and 1000 number 8. Clear this one. And 1001, okay, the number 9, and 1010 for the number A here, and 1011 for the number B, and 1100 for the number C, and 1101 for the number D, or we can say that 1110 for the number E, and lastly the 4 ones 1111, okay, 1111 for the number E, for the number F. Clear this point here. So like that also we can complete this column. So we know that here this is the decimal decimal column, this is the binary column and the hexadecimal column. Now that's why I am going to tell, why I am going to explain. Actually our conversion is the hexadecimal to the binary conversion, but we know that before going to convert any number from hexadecimal to the binary conversion, we should know this table. Clear this point here? We should know this table, then only we can convert any number that is from the hexadecimal to the binary conversion. Now let's how I am going to use in this case. So for example, one question, the question is the consider hexadecimal number, as we know that we are in the same conversion, hexadecimal to the binary conversion. So consider hexadecimal number, the number is the CEBA, okay, the CEBA, and we know that it is there in our hexadecimal conversion. Now just we need to convert to the binary conversion, as we know that the base value of the binary is the 2 and 16 is the base value of the hexadecimal number. So this question we need to convert, that is from the hexadecimal conversion to the binary conversion, okay, here the hexadecimal number to binary conversion. Now with the question we know that CEBA, okay, and we know the equivalent value, the C value is equal to 12, so I already written, and later next one E value is equal to 40, B value is equal to 11, and later A value is equal to 10, correct? Now A value is equal to 10. Now let's the value in this case here. So the first value 12, the value is the 1100, okay. So 12 value, now I'm just going to select from the binary column. So the value is the 12 value is the 1100, okay, this value I just selected here, and later next value is the 14, as we know that the next value 14, that is the E. So 1110, clear this point here. So just I selected this value 1110, and the B column value is the 11. So the value is 1011 here, and later the A column is the 101010, clear this point. Now just I completed all those values that is from the binary column, correct? No, I just completed for your easy method. I completed the number from our hexadecimal as well as I completed the number from the binary column. Now whatever the number I completed, now just I am going to write, that is from the left to the right, okay. I am going to write the number from left to the right. So first of all I am selecting the number 1100. So just I return this number 1100, and later next one 1110, okay, and next number 1011, and the last number is the 1010. So here we can say that now whatever the number is there in our 1 and 0 only, as we know that the base value of the binary is 2 and the numbers are 0 and 1. So here when you are going to check whatever the numbers are there, the number is there in our 1 and 0 only. So this is the answer of our consider hexadecimal number CEBA to binary, and finally we need to use the binary base value. So clear this point. So this is the answer. The answer is the just how I return, just I selected, I returned the value that is from the left to the right. So 1100, 1110, 1011 and 1010, and sure we need to write the base value. So the base value of the binary number, that is the 2 only. So I completed by using the base value. So clear this point here. How we need to complete in this case, okay. Now maybe the next number, let's for example the second example shall we use. The second example is about our bed. Clear this one here. The second example is the bed. In this case how we are going to convert, maybe the bed. In this case here the question name is the bed. So here we need to convert. First of all we need to select the B means 11, okay. The value is the 1011, clear this one, and later next one the E value is the 14, okay. The E value is the 14 and the value is the 1110, clear this one, and last value is the D, that is equal to 13 value, and the value is the 1101. Now how we are going to write the answer? So answer 1011, 1110, 1101 and the base value of 2. So this is the answer of our conversion, the conversion from hexadecimal, that is the question bet, the base value 16 to our binary conversion. So answer 1011, 1110, 1101 and should write the base value. So clear this part, how we are going to convert from the hexadecimal to the binary conversion. As we know that before going to convert any number, before that only we should know the table, correct no kya? So how the value going to use in the table kya? And later after the conversion, that is from our hexadecimal conversion to the binary number, next conversion, let's see the binary to the hexadecimal conversion, okay, the binary to our hexadecimal conversion. So in this case, before going to convert any number that is from our binary to the hexadecimal, as we know that first of all whatever I converted that is from hexa to the binary. Now our question is, now in this question we are going to convert from binary to the hexadecimal conversion. Clear this one? Okay, now in binary to the hexadecimal conversion here, so in this case the binary digit, clear this one, we break the binary digit into a group of 4 bits. So how many bits are there here totally? As we know that in binary group, when you are going to think about the binary column here, how many bits are there in each group? In each group totally there are 4 bits are there. So we can say that when you are going to convert any number, that means from our binary to the hexadecimal conversion, sure we need to break the binary digit into a group of 4 bits. Clear this one? Into a group of 4 bits and starting from the binary point, that means we are need to convert from the right side. Clear this one? So maybe one question 10110001, okay, so this is the question. So how we are going to make the conversion? We need to start from the our right side. Clear this one? We need to start from the right side and later, that means here we can say that each group have the 4 bits, correct no? And later we can say that here for whole number, maybe when you are going to think about the 4 bits are there in one group 4 bits. So what's the number I selected in 4 bit? The numbers are 1001 here, and here just only 3 values are there, 3 numbers are there. That means we know that for whole numbers it may be necessary to add 0 in MSB level, correct no? So this level is called as the MSB and this level is called as the LSB here. But in case of the maybe just only the 3 bits are there, but we know that in one group totally 4 bits are there, correct no? In our binary number, so how it possible to make the group into a 4 bits? That means sure we need to add the 0, okay, just to convert to the whole number. So we can say that for whole number it may be necessary to add 0 in our MSB level, just only to complete a grouping of 4 bits. Clear this one? To complete a grouping of the 4 bits here, or maybe if any fractional part is there, then sure you are going to add the 0 in our LSB level. Later what, let's see, shall we first of all will complete this question. Clear this one? Now just we complete it. Now let's, what's the answer? 0101, okay. So in this table we need to find out where is the value is the 0101 in this case here. So when you are going to, so first of all the value is about our 0101, okay. So 0101, that means the value is the 5 in this case. So 0101 here, the value is the 5, okay, 0101. So when you are going to, so this value is here. So 0101, the value is the 5, correct. Now here we are going to convert from binary to the hexadecimal conversion. So this is the hexadecimal column. So 0101, the number is the 5 and the next number is the 1001. That means the number is the 1001, the number is the 9. Clear this one? The number is the 9. So we can say that the answer is the 59, okay. So 5, how we got the number 5? 0101, that means we know that the 0101 one binary number in front of the 0101, we will get the number is the 5 here, and later next one 1001, that means 1001, the number hexadecimal number that is equal to 9. So like that we got the answer. So find 9 here, and lastly we need to use the base value. So clear this point here. So this is the answer of the 5, 9. And about the fractional part of our, or while representing the fractional, it may be necessary to add 0 in LSB. Later let's see, we will complete this question, or later we will complete the other part of the question, that is from our binary to the hexadecimal conversion. Now after completing one simple question, that is from the binary to the octal conversion, we already know how we converted this one, the last question here. Now let's the second question, and here also I am going to convert some of the conversion. The conversion here we can say that means the binary to the hexadecimal conversion. Clear this point here, the binary to our hexadecimal conversion here, also the hexadecimal conversion. So how to convert the binary to the hexadecimal conversion? As we know that I already explained, that means our we break the binary digit into a group of 4 bits starting from the binary point, correct? No, we need to start from the right side here, and just only we need to make in one group 4 bits, correct? We break the binary digit into a group of 4 bits starting from the binary point here, and convert each group into its equivalent hexadecimal digit. How we converted the last question answer, just to depend on the number. Maybe the number is 1001, that means we need to write the number as the 9, or maybe the number is 0101, that means we need to write the number as the 5 here. So depend on the number here, what's the number we will get. We know that in our table such number is that, so we need to equal to such number, and later we need to write the answer of our binary to the hexadecimal conversion. So in this case, as we know, for whole number, maybe in group 3 values are there, 3 numbers are there, then how it possible to make such group into 4 bit? That means sure we need to add the 0 in our MSB level here. But maybe while representing a fraction, so in this question, the question is the 0.1101 0110111. So this is the question, okay? So how to make the conversion, that is from our binary to the hexadecimal conversion? Again I am going to repeat the question. What's the question? The question is the consider binary number 0, fractional point 1101 binary to the hexadecimal conversion. So in this case we can say that the question is 01101 here, and later 0111, correct? No, so this is the fractional. So while representing the fraction, so this is called as fractional, okay, fractional point. While representing the fraction, it may be necessary to add 0 in our MSB, that means in our LSB level. Clear this one, how we are going to make? So after that we need to start here, 4 bits are there, and here also the 4 bits. I think here no problem, that means the each group have the 4 bit. Maybe if any one number is missing, then sure you need to add the 0. But here in this program, in this problem, no any problem in this case. Why? Because whatever the numbers we need in one group 4 bits, all those numbers are there, so no problem, no need to add any 0 value in our LSB level. Clear this one? Artha aita ellarige? Elladu ನಾವು ಈ ಫ್ರಾಕ್ಷನಲ್ ಪಾಯಿಂಟ್ ಇಂಥ ಎಲ್ಲ ಪ್ರೋಗ್ರಾಮ್ ಇಂಥ ಪ್ರಾಬ್ಲಮ್ ಇದ್ರೆ ನಾವು ಹೇಗೆ ಮಾಡ್ತೇವೆ? ದಟ್ ಮೀನ್ಸ್ ಇಟ್ ನೀಡ್ ಟು ಸ್ಟಾರ್ಟ್ ಫ್ರಮ್ ದಿಸ್ ಮ್ಯಾನರ್. ಕ್ಲಿಯರ್ ದಿಸ್ ಒನ್? ವಿ ನೀಡ್ ಟು ಸ್ಟಾರ್ಟ್ ಫ್ರಮ್ ದಿಸ್ ಮ್ಯಾನರ್. ಫಸ್ಟ್ ಆಫ್ ಆಲ್ ವಿ ನೀಡ್ ಟು ಟೇಕ್ ಇಂಟು 4 bits in one group. So I just taken the value 1101 and the next value our 0111. That means in one group 4 bits are there, in second group also 4 bits are there. So now just I am going to find out the value. So 1101, okay? So 1101, so value is the D. Clear this one? 1101, that means the value is the D here, and later next one 0111. Clear this point here? In this case, we can say that, so totally we can say, so first value is the 1101 here, and the next value here we can say that actual the value is our, now let's the second one, and in this question now we are going to take the fractional point. Clear this one? In this question we are going to take the fractional point. The conversion is the same, there is no any changes, and here also we are going to make the conversion from the binary to the hexadecimal conversion. Now let's, what's the question? The question is, consider binary number 0, fractional 11010111. As we know that the question is the 0 and 11010111. Correct? No? So this is the question. Clear this one? Now this question I need to convert, that is from the binary to the hexadecimal conversion. So first of all we know that maybe it's a whole number. Whole number means maybe if any value 11011111. Clear this one? In this case here, so how we need to, that means this is the whole number, there is no any fractional, whether any point is that, when you are going to compare this, in this question we used the fractional point, but in this question no any fractional point is there. So no any fractional point means where we need to use the 0 if the number is not equal to in one group 4 bits, but here the 4 bits are there, that means sure no any problem. But maybe if the value is 0 here, then sure we need to add how many 0? We need to add the 4 0. Clear this point here? So we need to add, maybe in this case just only the 0 is there, that means we know that in one group we need to use the 4 bits. Clear this point? So just only we need to use the value here, that means maybe in our no any fractional point, on that time we need to add the 0 in our MSB level in order to complete a grouping of 4 bits. Correct? No, in order to complete a grouping of the 4 bits, but in case of our fractional point where we need to use the 0, that means we can say that actually 1101 4 bits are there, and later next one is here also the 4 bits are there, no any problem. But maybe in this question, just when you are going to think about, just only after that, first of all we'll got the 1101 4 bits, but in our second just only 3 bits are there, that means sure we need to use the 0. Clear this point here? We need to use the 0, but in this question no any problem, whatever the bits are there in one group 4 bits they already given in the question, so we can use the 1 in this case. Clear this point here? So maybe if any value is missing, that means in our fractional point while representing the fraction it may be necessary to add a 0 in our LSB. ಅರ್ಥ ಆಯ್ತಾ ಎಲ್ಲರಿಗೆ? ಆ ಕ್ವಶನ್ ಯಾವುದೇ ಒಂದು ಕ್ವಶನ್ ಫ್ರಾಕ್ಷನಲ್ ಪಾಯಿಂಟ್ ಕೊಡದೆ ಇದ್ರೆ ಆ ಕ್ವಶನ್ ಅಲ್ಲಿ ನೀವು ಎಲ್ಲಿ 0 ಆಡ್ ಮಾಡ್ತೀರಿ, ಜಸ್ಟ್ ಟು ಕಂಪ್ಲೀಟ್ ಎ ಗ್ರೂಪಿಂಗ್ ಆಫ್ 4 bit you need to add a 0 in our MSB level here. Maybe it's a, in our question if they given the fractional point, that means sure you need to add the 0 in our LSB level. Clear this one here? LSB level here. So 1101, that means where about the 1101 the value is the 1101, that means the value is the D. Clear this one? 1101, so this value I taken, so 1101, okay here, and later next one is about our next one 0111, okay, so 0 3 ones are there, that means we can say that the value is the 7, but here fractional point is there, if you want you can add the 30. Clear this one? You want to add the 30 here just to complete a grouping of the 4 bits, so value we can say that the question answer is the question answer is here, we can say that the question answer is the 0 point and 0 fractional D7, and we know that the hexadecimal. So clear this point here? So like that we need to convert, that is from our binary to the hexadecimal conversion. Lastly I want to say some important note about this one. Maybe it's a whole number, then sure you need to add the 0 in our MSB level. As we know that maybe the value 1000 is there, so this level is called as the MSB, and 0 this level is called as the LSB. So maybe for whole number it necessary to add the 0 in our MSB level. Maybe while representing the fraction, in this case we need to add the 0 in our LSB level. So this is the important note about the conversion from our binary to the hexadecimal conversion. So clear no about this one. Now let's, after that we'll complete the next conversion, maybe the octal and to the hexadecimal conversion. Now let's, after that we need to complete the next conversion. The next conversion name is the octal to hexadecimal conversion. Now we are not in the binary to hexadecimal conversion. Now just we changed our conversion. The conversion name is the octal to hexadecimal conversion. But before going to tell the octal to hexadecimal conversion, important note or rules about our octal to hexadecimal conversion. The first note, write binary equivalent of each octal digit. That means here in this table or while going to convert any conversion from octal to hexadecimal conversion, not just only the hexadecimal table, with that we need the octal table also. As we know that we already know how to use the octal table. In our octal digit, it contains totally 8 digits. The 8 digits are the 0, 1, 2, 3, 4, 5, 6, 7, and we know that is equivalent to binary number, 3-bit binary number. So here 40, 41, 20, 21, 2021, 01, 01, 01. So like that. So we can say that. So this table is the hexadecimal table, and whatever I completed inside, this table name is the octal digit or the octal table. So just to convert from octal to the hexadecimal table, we need hexadecimal table as well as the octal table here. Now we know that first of all, write binary equivalent of each octal digit. Now first of all, the question is, consider an octal number 274, that means octal to the hexadecimal conversion. Just depend or based on the base value, we can say that means it going to convert from which number to which number, correct no here, from which to our next number. So here just only the base value is 8, that is equal to octal base value, and here just we are need to convert to the hexadecimal conversion. Now the question 274. So but what about the first step? Write binary equivalent of each octal digit. So now the number second, clear this one, the number second, that means the number second 010. Okay, so the number second 010, and the number 7, the number is the 111. Okay, the number is 111, and the number 4, that is equal to 100. So now just I am going to write all those value. So now just I completed the first step. The first step is the write binary equivalent of each octal digit here. I already completed the first step. Now let's the second step here. Regroup them into 4 bits. So how many bits we need to make it? That means we know that we need to move from the right side, correct? No, regroup them into 4 bits from the right side. Clear this point here? From the right side with zeros added if necessary. If you want to complete into the 4 bits here, we need to, because we know that the conversion going to start from octal to the hexadecimal. In our hexadecimal binary equivalent 4 bits, so we need to convert in one group 4 bits here. So and here how we are need to move, that means regroup them into 4 bits from the right side with zeros added if necessary. So first of all I am going to complete, I am going to take the value 0011, and later next one after that I am going to take the value, next value, that is 1101. Clear this point here, the 1101 clear in this case, and later now just only 1 0 is there, that means sure we need to take how many zeros? The 3 zeros we need to add it here. So clear this point here. So like that we need to make the group. So first of all 1100. Okay, first of all shall we start from this point here. So in this case we can say that here 00, that means no any problem, the value is the 0. So the third point is the convert each group into its equivalent hexadecimal digit. So first of all 4 zeros are there, that means no any problem. The starting step only 4 zeros, so just I return the value 0. Next step 1 0 1 1, so 1 0 1 0 1 1, that means the value is the B. Okay, the value is B. And later next one, last one 1 1 0 0. Okay, so 1 1 0 0 here, so value we can say that the value is the C. So like that we can convert, and so answer is the 0BC. Okay, the 0BC, and we need to convert into the hexadecimal conversion. So clear this point here, how we need to convert, just depend on the, we need to follow some of the steps of our octal to hexadecimal conversion. If you know all those steps, very easily you can find out the answer of our octal to the hexadecimal conversion. We need all these steps. The first step is the right binary equivalent of each octal digit. Clear this point here, the binary equivalent of each octal digit. ನಾನು ಏನು ಮಾಡಿದ್ದೇನೆ 274 ಅಂತ ಕ್ವಶನ್ ಅಲ್ಲಿ ಇತ್ತು. ಸೊ ಜಸ್ಟ್ ಐ ಫೈಂಡ್ ಔಟ್ ದಿ ವ್ಯಾಲ್ಯೂ ಫಾರ್ ದಿ 2 just by using the octal table. So 2 value is the 010, 7 value is the 111, 4 value is the 100. So after finding the first step, after finding the value for the first step, then I go for the second step. In second step, regroup them into 4 bits from the right side. So how I started, I just want to select, okay, in one group 4 bits. So I started from the right side. Here arrow is that means I started from the right side. So in one group I completed the 4 bits, and after that, after completing here, just I got the 10. So just to complete this 0 into a group of 4 bits, I completed, I added 3 other zeros. So that means I can complete the grouping of the 4 bits. And later next one, step 3, convert each group into its equivalent hexadecimal digit. Just only the value, for the value correctly we need to find out. Okay, so 0, that means no any problem, 0. After that I found the value for our 1011. So 1011, the value is the 1011, the value is the B. So I return as the B. And lastly 1100, clear this one, 110, the value is the C. So like that I can find out the value for our octal to the hexadecimal conversion just by taking or using the question 274 octal to the hexadecimal question answer 0BC to the hexadecimal conversion. Now after completing the anything from our octal to hexadecimal conversion, now let's the next conversion is the hexa to the octal conversion. Clear this point here, the hexadecimal to our octal conversion. Okay kya, so now the next conversion, the hexadecimal to our octal conversion. So in this case, now let's, what are the steps we need to follow in our hexadecimal to the octal conversion. So the first of all, the first step, there is no any changes, just only the slight changes in between our octal to the hexadecimal conversion and also to our hexa to the octal conversion. Now just we change the conversion name. The conversion name is the hexa to our octal conversion. So this step 1, right, binary equivalent of each hexadecimal digit. Okay, now first of all, the question I want to read as the question. The question is the, consider hexadecimal number. The question is the FADE, F-A-D-E, FADE hexadecimal to the octal conversion. We know that, we know the side heading or the heading, that is the hexa to the octal conversion. So the question is the FADE, we need to convert to the hexa to the octal conversion. So first of all, the FADE value is there, no, whatever I said in this step 1, right, binary equivalent of each hexadecimal digit. So in this case we can say that first of all I am going to write F-A-D-E, this is the question. Now depend on our binary equivalent, I am going to select the hexadecimal digit. Clear this point here, so hexadecimal digit, so the first of all is the F. So I am writing as the 4 ones, so F, that is equal to 41. Okay, the binary equivalent of each hexadecimal digit, so F 41 A value is the 1010, 1010, D value is the 1101. So I written here, and E value is the 1110. So totally whatever the values are that is equal to binary equivalent of hexadecimal digit, I completed here. Clear this point? Okay, now let's again I need to write, okay, this number. So whatever the number is there, I completed by using the binary equivalent of each hexadecimal digit. The same value I completed here. Now the value 1111, okay, 1010, 1101, 1110. So we know that. Now go to the second step. Okay, regroup them into 3 bits. That means we know that here we need to convert from the hexa to the octal conversion. So we know that regroup them into 3 bits from the right side. Clear this one? How we need to move? That means we need to move from the right side here with zeros added if necessary. So here that means 3 groups we need to make. The first group is the 0, 1, 1. The second group is the 1, 1, 0. The third group is the 1, 1, 0. Now next group is the 1, 0, 1. And next group is the 111. That means here just only the number 1 is that, as we know that just to make it into our group, okay, in one group 3 bits are there. So we need to add 2 zeros. Clear this point here? We need to add the 2 zeros in this case here. So like that we need to make it. That means the third one, convert each group into its equivalent octal digit. Artha ಆಗ್ತಾ ಇದೆಯಾ? ನಾನು first of all ಏನು ಮಾಡಿದ್ದೇನೆ? The first step I converted the fate, that means depend on the binary equivalent. I used the value for F, A, D, E, and the same value I completed here. And later next one, after completing the step 1, then I go for the step 2 and regroup them into 3 bits. Clear? And how I started? I started from the right side and I added the 0. If you want to add any 0 just to complete a grouping of 3 bits, I added 2 zeros here. Now later next one, now just I am going to write the answer. So the third step, convert each group into its equivalent octal digit. That means we need to use the octal digit table also. So first of all 001. So whatever the value is that 001. Okay, so 001 the value is 1. After that, that means we completed this value. Okay, later next one 111, the value is the 7. Clear this one? The value is the 7. 101, that means the value is the 5. That means we completed this one. Okay, we already completed this point here. Now 011, so 011 the value is the 3. Clear this point? Now we completed this one 011. Again the value 011, that means here the value again we need to write as the 3, and the last value is the 110. So that means we can say that the answer is the 175336. Clear this one? 175336, and we need to convert to our octal conversion. So this is the answer about our hexa to the octal conversion. That means here also we need to follow some of these steps. So the important steps, that is the conversion from hexa to the octal conversion. Write binary equivalent of each hexadecimal digit, and second, regroup them into 3 bits from the right side with the zeros added if necessary, and third one, convert each group into its equivalent octal digit. So clear this point here? So like that we can convert the conversion from one to another. So thank you for watching this video.
Don't forget to like our video and subscribe our YouTube channel for all the updates.